When you think about solar power, you probably picture these huge fields of panels, right? Just soaking up the sun. But what you can't see is this invisible river of data that's flowing from every single one of them. And that data, well, it's like a secret language. And understanding it is the difference between $1 billion success and a really expensive failure. So let's dive in and decode how we actually give a solar power plant a report card. I mean, first, you have to appreciate the scale we're talking about. These aren't just a few panels on a roof. They're sprawling, incredibly complex power plants. We're talking millions of individual parts. Panels, cells, inverters, trackers, sensors, all have to work together perfectly. The sheer size of it all is just mind-boggling, and trying to manage it is a massive challenge. So you gotta ask, right? With millions of components, and then you throw in Mother Nature, unpredictable clouds, dust, scorching heat. How in the world do you know if one of these giant plants is actually doing what it's supposed to do? How do you know if it's an A student or if it's failing? Well, the answer comes down to a kind of universal language that everyone in the solar industry speaks. It's called Key Performance Indicators, or as you'll always hear them called, KPIs. This is how we take all that chaos and complexity and distill it down into simple, powerful numbers that actually mean something. Honestly, the best way to think about it is like the dashboard in your car or maybe a fitness tracker on your wrist. It's taking in thousands of complex signals every second, but it boils them all down to just a few vital signs. A quick glance and you know exactly how healthy the plant is and if something's wrong. And those vital signs basically fall into three big buckets. First up, you have the technical KPIs. These are like the check engine light. They answer one simple question. Is the hardware, the actual equipment, doing its job properly? It's all about measuring what the plant is actually producing versus its absolute maximum potential. Next, you've got the economic KPIs. And this is all about the money, the bottom line. These track everything from how much it costs to build the thing in the first place to how much it costs to run it every day. They answer that all-important question. Is this giant power plant actually making any money? And finally, there are the sustainability KPIs. These are the ones that ask, okay, but is it actually good for the planet? They calculate things like the overall carbon footprint, but also something really cool called energy payback time. That's how long it takes for the plant to generate more clean energy than all the energy that was used to build it. And for modern panels, believe it or not, that can be less than a single year. So here's the key takeaway. You can't just look at one of these. You need all three to get the full story. A plant might be running perfectly from a technical standpoint, but be a financial disaster. Or it could be making tons of money, but not really delivering the environmental bang for the buck that we expect. Real success is right there in the middle, where all three of these things overlap. So let's make this real with a classic example. One of the most important technical KPIs is called the performance ratio, or PR. It's basically the plant's grade. It takes the energy the plant actually made today and compares it to what it should have made, given the exact amount of sunlight it got. A high PR tells you your equipment is in tip-top shape. It's super simple, but super powerful. Okay, so we've got these really smart numbers, but they're not just for engineers sitting in a control room. They are the language used to make billion-dollar decisions. Let's take a look at who's using them and why they matter so much. And what's so fascinating is how these KPIs become this common ground for everyone involved. You've got banks looking at these numbers to decide whether or not to even loan the money to build the plant. You've got the asset owners, the investors, watching them like a hawk to track their profits. And then you have the crews on the ground using them to hunt down and fix problems. These numbers are literally written into contracts worth millions of dollars. But you might be wondering, where do these perfectly clean, reliable numbers come from? Because trust me, they don't start out that way. The journey from a single ray of sunlight hitting a panel to a trustworthy KPI on a screen is actually a pretty wild ride. It all kicks off right there in the field. You've got weather stations measuring every bit of sunlight, sensors on the panels checking their temperature, and inverters converting the power. All of that information, thousands of data points every single minute, gets fed into a central system, basically the plant's digital brain, called a SCADA system. But, and this is a huge but, that raw data is messy. I mean, really messy. A sensor can get a little bit of dust on it. An inverter might shut down for a few minutes. A network connection could drop. If you just use that raw, unfiltered data to calculate your KPIs, your results would be completely useless. Garbage in, garbage out. which is why every single piece of data has to go through this intense cleaning process. First, you collect the raw stream. Then, smart algorithms scan through it, identifying and flagging anything that looks weird, spikes, dips, or gaps. That bad data is either totally thrown out or the gaps are intelligently filled in. And only then, after all that filtering and cleaning, can you finally calculate a KPI that you can actually trust. Okay, this is where it gets really cool, because once you have these clean, reliable KPIs, you can start using them to make incredibly smart decisions that have a huge impact on the plan's performance and profitability. Let's talk about a really common enemy of solar panels: dust. It sounds simple, but in dry desert climates, just a thin layer of dust and grime can slash a plant's energy output by more than 15%. That is a massive financial loss, just from a little bit of dirt. You know the saying, you can't manage what you don't measure. So, of course, we have a specific KPI just for this problem, the soiling ratio. It calculates the exact percentage of energy you're losing to that dirt. So now, instead of just guessing, the operators know with certainty the precise moment when spending money to clean the panels will earn them back more money and extra energy. It's a simple calculation that can save millions. And this right here is a perfect example of data driving action. On the left, you see a thermal image from a drone. Those bright hotspots, those are individual modules that are failing. And on the right, you can see the plant's performance data with these very clear step-by-step drops in output. By putting these two pieces of data together, the team could pinpoint exactly when each part failed, calculate the financial loss, and then boom, go in, replace them, and bring performance right back up to where it should be. Now let's talk about the ultimate economic KPI. It's called the levelized cost of electricity, or LCOE. Think of this as the true all-in price tag for solar power. It takes every single cost, from construction to maintenance to financing, over the entire 30-year life of the plant and boils it down to the average price of one single kilowatt-hour of electricity. And why does that one number matter so much? Because a lower LCOE means cheaper energy for all of us. And thanks to this relentless focus on data and squeezing out every last drop of efficiency, many brand new solar projects are hitting an LCOE below 3 cents per kilowatt hour. That makes it one of the absolute cheapest sources of new electricity on the planet, period. So when you zoom all the way out, you realize this obsession with data, with KPIs, with performance, it's not just about making one power plant run better. It's about what makes the entire global shift to clean energy actually possible. Think about it. By collecting and analyzing performance data from thousands of sites all over the world, we learn exactly how different types of solar panels hold up in different conditions. And that knowledge feeds right back to the engineers, who can then design tougher, more efficient technology that's tailor-made for the brutal heat of the desert, the sticky humidity of the tropics, or even the snow and cold of the far north. Data is what drives innovation forward. So at the end of the day, it really is all about the data. It's the secret ingredient that transforms a simple piece of silicon into a smart, cheap, and incredibly reliable power plant. We've used it to make solar a true cornerstone of our energy future, which leaves just one question. What big problem should we point all this data at next?